Good morning, friends. Today we shall discuss the next point, that is um, VI, characteristics of PN junction diode. In the last lecture, we have discussed about the formation of PN junction diode, its operation in forward bias and reverse bias, the meaning of the depletion region, meaning of the internal potential barrier, and so on. Now today we shall see the VI, characteristics of PN junction diode. Friends, we know there are two types of VI, characteristics of PN junction diode. They are forward characteristics as well as reverse characteristics. Now when PN junction diode is forward bias, then we plot forward characteristics, and when PN junction diode is reverse bias, we plot reverse characteristics. When we have to plot the forward characteristics, we apply positive voltage to P region and negative voltage to N region. Then we increase the voltage step by step, and for each value of voltage we note down the current. We increase the voltage like 0.2, 0.4, 0.6, 0.8, 1 volt, 1.2 volt, and so on. So we increase the voltage in equal step, that is called as forward voltage, and for each value of the forward voltage we note down the forward current, and then we plot the graph. We plot the graph by taking voltage on x-axis and current on y-axis, and that graph is called as forward characteristics. Now you can see in the book forward characteristics, they are plotted in the first quadrant of the graph paper. We know there are 4 quadrants. In first quadrant we take 2 positive quantities. In second quadrant we take 1 negative, 1 positive quantity. In third quadrant we take 1 negative, 1 both negative quantities. And in fourth quadrant we take 1 positive and 1 negative quantity. Since here both voltage and current are positive, we plot the graph in first quadrant. Now from the graph it is clear that initially when we increase the voltage, supply voltage or forward voltage Vf, then forward current If is 0. Beyond a certain value of the forward voltage, the current If flow in the diode, and when we increase the voltage, then current I through diode increases by a large amount. So it is clear that here initially when we apply the voltage, forward voltage, then forward current is 0. Why? Because initial voltage is opposed by internal potential barrier, whose value is 0.7 volt for silicon diode and 0.3 volt for germanium diode. Since initially applied voltage is less than internal potential barrier voltage, the current through the PN junction diode is 0 because there is no crossing of the electrons and holes through junction. But as soon as the applied voltage became slightly greater than internal potential barrier voltage, then the internal potential barrier voltage vanishes, and therefore there will be crossing of the holes and electrons through junction, and hence current flow through PN junction diode. And if we increase the voltage again, then the speed of this carrier increase, and therefore more and more electrons and holes are formed, and therefore current increase by a large amount. So in this way PN junction diode have 0 current for initial voltage and high current for final voltage. Since current is high, we can say that when a PN junction diode is forward bias, it offers very low resistance to the flow of current. Now we shall discuss about the reverse characteristics. Now reverse means opposite. Opposite means negative. Now when PN junction diode is reverse bias, then we can plot reverse characteristics. Now in this case we apply negative voltage to P region and positive voltage to N region. So here we make PN junction diode as reverse bias. Now in this case we have to connect microammeter to measure the current because current is in microampere, and voltmeter to measure the voltage. Here also we can say that if we increase the voltage step by step, that is suppose 0.5 volt, 1 volt, 1.5 volt, 2 volt, then current remain constant. Current doesn't increase. Just unlike in previous case, if we increase the voltage, current increase by a large amount. But in this case, when we increase the voltage, current almost remain constant because this reverse current is due to minority carrier. So we plot the graph by taking voltage on x-axis and current on y-axis in third quadrant, because here we apply reverse voltage and therefore current is reverse, means both are negative, and therefore we plot the graph in third quadrant. Now what is the reason behind this? When we increase the voltage, the current almost remain constant. The reason is, in this case, current flow mainly due to minority carriers, that is electrons in the p region and holes in the n region, and therefore this minority carrier remains same in number when we increase the voltage, and therefore current due to them will be remain constant. But how this current increase? It increase when we increase temperature of the junction. When temperature of the junction increase, then electrons in the covalent bond gains energy, and therefore they became free from the bond by breaking bond, and hence more and more electrons and holes are formed in this way. So when temperature of the junction increase, then these minority carriers increase, and therefore reverse current also increase. So the reverse current in this case mostly depends on the temperature, not depends on the applied reverse voltage. So it is all about the forward and reverse characteristics of PN junction diode. Then we shall discuss about symbol of the PN junction diode. Symbol you can see in the book, the symbol is just like a arrow. On left side of the arrow we write P or A. P means P region, A means anode. On the right side of the arrow we write N. N means N region, or K. K means cathode. So the current flow in only one direction, from anode to cathode, when PN junction diode is forward bias. It is the meaning of the symbol of PN junction diode. So it is all about the forward and reverse characteristics of PN junction diode. In the next lecture we shall discuss about the applications of the PN junction diode, how it can be used as half wave rectifier, full wave rectifier, as well as full wave bridge rectifier. So that is applications of the PN junction diode. All these we shall discuss in the next video. Till then, goodbye. Please like, share my video and subscribe my channel. And if you have comment, you can write it in the comment box so that I will improve my further video. Okay, thank you.